Okay, so let's clear this now. And we'll go and use a math block here. All right, so let's take just an ordinary, plus block here, and you can see to JavaScript we get the 1 plus 1. This isn't put in any type of other block, so we're not going to worry about the parentheses. Let's actually look at the generators for math blocks now. So here we're actually looking at math arithmetic blocks, and again, you can see that by doing export to XML, and you'll see the type is math arithmetic. But what you'll notice over here is that the operators, you're associating the different operators here with different precedences, right? Because you have order addition if the plus is being selected, you have order subtraction if the minus is being selected, order multiplication, order division, and then you might also wonder over here why power is using order none, right? You would think maybe it would be using the order exponentiation over here. But actually what it's doing over here is you could see when it's using exponentiation, you could see that the code that will be generated, this is a special case, where it's using not the new exponentiation operator in JavaScript that wasn't available previously. Previously we used math.pow. So math.pow, you could see this is going to be a little different here. Argument 0 and argument 1 are both going to just be surrounded here by an open parenthesis, a comma, and over argument 1 here this is the comma and the closed parenthesis. So again, argument 0 and argument 1 are not going to be split, right? So whatever you put when you do something like exponentiation here, not times, the caret, and if you put in, let's say, two numbers here, I don't know, make these different. You'll see that it's just putting it in math.pow, right? So these numbers won't be split anyway, but you don't have to worry about that, right? Because no matter what you put in here, even if you put in, let's say, an addition block here, right, that would not get split, right? Even though exponentiation has a higher precedence than addition. Again, we're just using the old math.pow, so it's just being put as an argument to this function here, right? So it's not going to get split up. We don't have to worry about it, right? On the other hand, with Python, we would have to wrap it in parentheses because we're using the asterisk asterisk here for exponentiation, right? So I'll just go back to JavaScript because that's a different generator. That's the Python generators, right? So anyway, the thing I wanted to bring out here is the fact that we will be using different precedences based on the option that's selected. So if I did multiplication here and I go back to JavaScript, 123 plus 1 would be wrapped in parentheses, but if I changed this to, if I change this to multiplication, it's another one of those exceptions. So it won't be wrapped in parentheses, but just to make this so it's not one of the exceptions, right? If I put addition there, it won't be wrapped in parentheses either, right? So obviously, depending upon the operator that we use here, there are going to be different precedences. So you could see here that the way we handle this in the code is that we create this operators object and use the values of the field, right, as the property names. And you can see that the values, right, are going to be the operator and the precedence that we're going to use, right? So the whole point is we're going to use these different precedences even though we're using the same block here, right? So again, if you look at the code that is returned, it's going to be argument 0 plus operator plus argument 1. So it's just going to, if it's not, I should say, if we don't have the situation where we're in exponentiation as the operator, then we're just going to do argument 0 plus operator plus argument 1. And the way operator is gotten is just by tuple 0, right? So that's either going to be the plus, the minus, the times, the or the division there. And the order that's being passed over here and also over here is going to just be the corresponding precedence here, right? So over here, it turns out that the order that we're using for value to code for both A and B, so the inputs A and B, again, you can export to XML. You can imagine that this is going to be the A input and this is going to be the B input for the plus block, right? And you could again see that value name is A, and you can see that that's going to value name of A for that addition block is going to have the shadow. Well, I should get rid of this because this was there before. If you didn't have that, that's what that is. So let's get rid of that one because that's just going to confuse things. Right, so value name A, right, is going to be that math arithmetic with the multiplication block, right? And all the way up to here, and value name B, again, we'll get rid of that shadow block that was there before. Actually, we won't get rid of that shadow block because that's this one over here. All this nesting here. We'll get rid of this shadow block. This is the value number B for the addition block. We can see that it'll be the math number with 534, right? So the reason that we wind up using the same orders for the arguments that we do for the return value or for the inputs that we're input blocks we're using and the return value for this math arithmetic block is because, again, when you look at the generated code, right, let's just simplify things. We had 123 plus 534. The 123 here is being put next to a plus, right? So if we have anything that has a weaker precedence than plus, than addition, it needs to be wrapped in parentheses. And similarly, this 534 is being put next to a plus. So if this block were something else and it had a weaker precedence than addition, it would also need to be wrapped in parentheses, right? But also the generated code is just going to be the numbers or whatever these inputs are. So again, I could just put a 123 times 1, whatever. So it's going to be this, the code generated from this block, and the code generated from this block, which will just be the 534. It's going to add them together. So again, we're talking about an operation that can be split is going to be addition. So we also return addition as the as basically the operator that we're going to use, the operator precedence for this addition block, right? But of course, if we change this to multiplication, then we would be returning a multiplication block or multiplication as the precedence, etc. So anyway, this is just a nice way of not putting a bunch of if statements here. You basically just use this lookup. So you could see tuple here is going to be operators of block.getFieldValue op. And again, if you export it to XML, you'll see that op will be something like multiply or add. So it's going to like look that up and multiply, let's say, and it's going to say, okay, multiply corresponds to this 2-item list with multiplication in Blockly JavaScript order multiplication, and it's going to use the order is just going to be the last of these items, and the operator is going to be the first of these items or 0th of these items, right? And it uses the operator for the code, and it uses the order to pass against these inputs A and B.